Okay, so 31, it says decide whether enough information is given to prove that the triangles are congruent. If so, state the theorem you can use. So it's wondering if this triangle is congruent to this one. And I gave you the hint of they're looking for like side, 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 angle, side, or angle, side, angle. For this, they show one angle in common. They show this side in common. And then because of the reflexive property, this side is equal to itself. But that gives you angle side side, which remember ASS is not a congruent statement, so therefore there's not enough information for this one. Late bus. Okay. Next, for number 32, this is what we did yesterday. Determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. So you're looking to see if the three angles match. If you have two angles that match, then the third one would match. Right here we can't quite see it, but if we do 180 minus 105 minus 28, we can get this third angle here, and that comes out to 47. So now we have two matching angles, 28 and 47, 28 and 47. That means the third angle would also match, so this must be 105. So therefore, yes, we have similar triangles. And as far as the similarity statement, your similarity statement might look a little bit different than mine, but what they're looking for is that whatever order you put this in, if you put the 105-degree angle first, then the 47, then the 28, you have to do that for the second one. So 105 degrees is angle H, then the 47 is I, and then I'll do the 28-degree last, HIG, is similar to triangle, and again, I have to do that same order. So 105-degree angle is N, then the 47 is M, and O is last. And that's the similarity statement. Okay, next one. This is from the last chapter. Little review. It says a stop sign is shaped like a regular octagon. An octagon has 8 sides. If you didn't know that, you could also count it on this stop sign. Find the measure of each interior angle and exterior angle. Okay, well, the interior angles sum to, and we use this equation. So for 8 sides, you would plug in 8 for n. 8 minus 2 times 180. Then 6 times 180 is 1,080. But that's all the angles combined on the inside of this shape, and it wants to know each interior angle. So once you have all the angles, then you would do 1,080 divided by 8 to get each one. And 1,080 divided by 8 is 135 degrees. So that's the each interior angle. Then for exterior angles, the exterior angles of any polygon sum to 360. We don't need to do any calculations to find the sum of the exterior angles, but again, it's wanting each exterior angle, so we'll do 360 degrees divided by 8 to find each one. And it comes out to 45 degrees for the exterior angles. And another key word in there that I'm going to point out, the reason why we know that all the angles are the same measure is because this little word right here. It says it's a regular octagon, and a regular polygon is a polygon that has all the sides the same length and all the angles the same measure. So that little word that seems unimportant, just regular, actually means a lot. Okay, 34. Measure of angle S. So it wants to know this measure right here. We have a kite. It's a quadrilateral, so the sum of the interior angles is 360 degrees. And also in a kite, these angles are the same measure, these opposite angles here. So I'm going to do 360 minus 64 minus 42, and that comes out to 254 degrees. That's what's left over after I take those two angles out. Then that 254 needs to be divided evenly among those two angles. So 254 divided by 2, and I'll get each angle, which which is 127 degrees. So 127 here and 127 here. Okay. 35. Remember when I cut things yesterday because we were getting interrupted so much? I didn't go over the last example I wanted to go over with you, and that was actually 35. So in this diagram, it shows that these two shapes are similar. The area of ABCD, this right here, is 288 square meters, so meters squared, that's the area. It says find the area of this smaller shape. Just like side length is proportional, area is proportional as well, but it's proportional in a different way. So if I take the side length, 24, and square it over the side length of this one, 6, and square it, that'll equal the area over the area of the little one. And you can solve for the area of the smaller one this way. So let's see what's the numbers. 24 squared is 576. 6 squared is 36. Then from here, you do your cross multiplication. You're dealing with some big numbers, but it's cool. And then x equals 18 meters squared. So that's one way to do it. My honors class also pointed out that if you forgot this like whole process, you could actually take the area here, divide it by 24. Let's see, if I did 288 divided by 24, let me grab my calculator. So if you did 288 divided by 24, you get 12, and that's this length here. And then you could use proportionality to find out this side length and then find the area of this that way, if needed. Just FYI. Okay, we're going to move on to 8.3 now.